Good morning, guys. It's April 1st. If I had more time and energy, I might have done an April Fool's thing, but I don't. So we're just going to get right to it. All right, so this is the short, I'll try to keep this as short as possible. The exit slip feedback from 2.4b and from 2.5. So I'll post it really quick, and I want you to pay particularly close attention to 2.4b. Most of you guys did really well in 2.5. But the 2.4b, there were some mistakes and some misunderstandings that I noticed when I went through the exit slip. So we're going to go through these 4 questions very quickly. All right, so you have an equation, 77 kilojoules of energy plus 2 NOCl, and that will give you 2 NO plus Cl2, and this is a reversible reaction. What would happen to the concentration of NOCl? So what would happen to this concentration if this concentration of NO were increased? So what we're being asked here is what happens to NOCl if we add more of this, okay? Which way would the reaction shift as well? That's my fault. So I would like to, one of the first thing I want to notice is when you are answering any of these questions, 1, 2, or 3, when you're answering any of them, the first thing you should be trying to figure out and think about is which way will the reaction shift? Is it going to shift to the left or is it going to shift to the right? Okay, so let's figure that out. We have a concentration question. So we are going to use our old seesaw analogy. Let me do all this seesaw work in a different color here. So we have our seesaw. We are told that the reaction is at equilibrium, which means at the beginning, it's all balanced, okay? Now, what happens if you add more NO? If you add more NO, NO appears on this side of the equation. So suddenly NO, it's going to get heavier on that side. So it's going to look like this. It's going to be out of whack, right? So you're going to have this heavier weight over here. That's the first part of this question. How is it going to get imbalanced? Now, to answer the first part, which way would it shift? This is when you think about what do you need to do to get it back to even. So this reaction, in order to, since it's heavier on this side and lighter on that side, so to speak, it's going to have to shift to the left. So the first thing you should have said, which way would the reaction shift? It would shift to the left. Okay? That's all the seesaw thing helps you figure out. So the first thing you should have said was that this equation will shift to the left. Okay? Now we're going to see some of the major misunderstandings that I saw. I'm going to erase all this. Since we now know it's going to shift to the left, I'm going to erase this all. And we're going to actually break down this question here. And I'm going to show you some of the other sort of ways that students are misinterpreting this analogy and sort of arriving at the wrong answer. So once you know this reaction is going to shift to the left, now it comes down to what does that mean for the question? So we know that adding more of this NO on the product side, it caused the reaction to shift to the left. So now what does that mean? A lot of you guys are not really answering the question. This happens every year. So if we add more NO, we wanted to know 2 things. What way would it shift? We know it's going to shift to the left. What's the other thing this question is asking us about? It wants to know what's going to happen to the concentration of NOCl. What's going to happen to the concentration of this reactant? Well, if we're shifting to the left, that means this reaction is shifting this way. That means the amount of NOCl is going to be increasing. It's going to be producing NOCl. In order to make more of NOCl, we are going to be using up the added NO and the Cl2. Okay, this is the major misunderstanding that we're seeing. Okay, so what's going to happen here? Once you know this reaction shifts to the left, whatever way you're shifting towards, in this case we're shifting left, whatever way you're shifting towards, those values are going to increase. Okay, whatever direction you're shifting away from, those values are going to go down. So if we're going from the right to the left side values are going to increase, the right side values are going to decrease. So what we're talking about is when we say these values are going to increase and decrease, we're saying that in terms of concentration, so of the 3 substances we have, NOCl, NO, and Cl2, those are substances that we can sort of, we can quantify their concentration. And then we have heat. So for the substances, those are concentrations. So the concentration of NOCl is going to increase. The concentration of NO, if we're shifting away from NO, is going to decrease, and the concentration of Cl2 is going to decrease. Also here we have heat. So heat is not a concentration, it's just a quantity of heat. If we are shifting towards the value of heat on the left side, the amount of heat that is produced in the reverse reaction is going to increase as well. So to answer the question, the first part, it's going to shift to the left. Second part, this value of NOCl, the concentration, will increase. So the two things I needed to see in your answer to get it right will be the concentration of NOCl will increase. Okay, now I'm going to go over a couple of the responses that I saw. So the concentration of NOCl will increase. Some of the big issues that I've seen both in today and yesterday's exit slip, as well as in years past, is students aren't really they're not necessarily certain as to what's increasing and decreasing. They say things like the reaction shifts to the left and the reaction increases, or the reaction decreases. They speak in terms of like the reaction, or they speak in terms of just generally speaking, the products will decrease and the reactants will increase. Be very careful, be very specific. This is, yes, some of you guys are saying the reaction shifts to the left, therefore the concentrations of my reactants will increase and the concentrations of my products will decrease. That is true, but also remember this question is asking specifically about the reactants. So don't be afraid to speak in very specific terms. Don't speak in terms of general, like the reaction shifts to the left and the reaction increases, right? We're not talking about the reaction increasing. We're talking about the concentration of NOCl, which is one of our reactants. Okay, let's look at number 2. We should be able to move more quickly through this. Let me do my erasing here. All right, so now I'm going to do all this erasing. The first question was asking about concentration. What happens to the substance at equilibrium if we change concentration? The second question asks about temperature. Okay, so what happens if we change the temperature? So remember, concentration and temperature, they both utilize the seesaw analogy. So let's go right to it. What would happen? Again, they are asking about the concentration of NOCl, which in this reaction, NOCl is on the reactant side. So they want to know about the concentration of this reactant if we increase the temperature. Okay, so we're talking about two things here. The concentration of this if we increase the temperature. Okay, so what happens? So if we increase the temperature, now let me do all my sort of seesaw work in green. Again, we are at equilibrium. Everything is even. Everything is, the rates of the forward and reverse reactions are equal and the reactions are constant. We're all sort of squared away. Suddenly we increase the temperature. Temperature is on this side. Temperature gets treated like a reactant in this case. So if we add more, it's going to go like this. It's going to get out of whack, kind of like that. So it gets heavier on this side. So the seesaw suddenly gets out of whack in the opposite direction as the previous question. Once you know that it's out of whack like this, now you can answer the first part. Which direction will the reaction shift? Well, in this case, the reaction is going to have to shift the opposite direction, to the right. Okay? And when we say the reaction shifts to the right, it means we have to create more products by using up the reactants. So what's going to happen is, as we shift to the right, the value, the concentration of NOCl is going to be decreasing. It's going to be used up to create more of the products. And in this case, the NO and the Cl2 are my products. Those are my concentrations of my products. So if the reaction is shifting to the right, the stuff on the right side of the equation will increase. And if the reaction is shifting away from the left, the stuff on the left is going to decrease. Okay, so if we increase the temperature, we are going to actually shift the equation to the right, and the concentrations of NO and Cl2 will both increase. But that's not what the question asked. The question asked about the concentration of NOCl. Well, if the reaction is shifting to the right, you are using up NOCl to shift it to the right to make more product. Therefore, the amount of NOCl will decrease. So your answer is the reaction shifts to the right. So the reaction will shift to the right. And the concentration of NOCl will decrease. NOCl concentration decreases. That was the answer I was looking for. Okay, some of the other things that I was getting, again, people saying like the reaction will shift to the right and the reaction will decrease. Speaking generally in terms of the reaction, be specific. You should be able to address every one of these substances in the equation specifically. So if the reaction shifts to the right, the concentration of NO would increase. If the reaction shifts to the right, the concentration of Cl2 would increase. If the reaction shifts to the right, the concentration of NOCl decreases. If the arrow were to go the other way, like in the previous question, it would all be flip-flopped. Okay? All right, number 3, we have a question on the number of moles. So this is the first one that we see in this exit slip that does not utilize the seesaw. It has a different rule that we follow. Okay, so we're going to get rid of all this seesaw stuff. Okay, and we're going to switch gears. The rule, think about what the rule was. The rule is an increase in pressure favors the side with fewer moles. And a decrease in pressure, if you decrease pressure, it favors the side with more moles. So it's all about quantifying how many moles you have on each side of the reaction. Okay, I'm going to write that off to the side. So an increase in pressure favors the side with fewer moles. Fewer moles. Now, this is the rule that you have to remember. It should be in your notebook. So an increase in pressure favors the side with fewer moles, and a decrease in pressure will be the opposite. If you have a decrease in pressure, it will favor the side with more moles. Okay, that's the rule. And once you know to activate that knowledge in your head, decrease in pressure favors the side with more moles. Once you know how to activate that knowledge in your head, and you know that you're using it, hopefully this question becomes pretty easy. But the real hard part about this question is just remembering that this is what you need to know to answer the question. You need to read this question here, number 3. You need to be able to read this, and your brain needs to go to this relationship over here. If your brain doesn't connect this question to this rule, then you will not get the question right. It's that simple. Okay, so here we go. Basically, just once you know that, just take your 2 sides. I'll do the reactants in red and the products in blue. How many moles do I have? Well, you only count the coefficients. So I have 2 moles of reactants on the left. And I'll do the products in blue. I have 2 moles of this reactant, and don't forget that hidden 1. And I have 1 mole of this product. Excuse me. I have 2 moles of this product, and I have 1 mole of this product. So I have a total of 3 moles of products. So it's already clear that the products have more moles than the reactants. The reactants have fewer moles than the products. So what are we doing? We are increasing the pressure. So we are increasing the pressure. So we're going to be using this relationship. We are increasing the pressure, meaning this reaction is going to shift to the side with fewer moles. Well, in this case, that is going to shift towards the side with fewer moles. So the left side has fewer moles. So this reaction is going to shift to the left. So the first part is going to shift to the left. Remember, I always start with which direction the reaction shifts. Okay? So the reaction will shift to the left. Once you know it shifts to the left, the stuff on the left side will increase. So this concentration goes up. The amount of heat produced will go up. And if we're shifting to the left, which is away from the right, the stuff on the right side will decrease. So this concentration will go down, and this concentration will go down. And this question is, again, asking about the concentration of NOCl. So once you know this reaction shifts to the left, the amount of NOCl, the concentration, will increase. So this shifts to the left, the concentration of NOCl increases. Concentration of NOCl decreases. Excuse me, increases. My bad. NOCl will increase. Okay, there you go. So those are the 3 questions on Le Chatelier's principle. The 4th one is a quick question here. I'm just going to write over the top of all this stuff. Is it exo or endo? Remember, when the reaction has heat as a reactant, it's endothermic. So this one is endothermic. If heat were over here, it would be exothermic. There is another way that off to the side, if they report the delta H as positive, it's endothermic, or if they report the delta H as negative, it's exothermic. You guys will pick that up probably in a lesson or two when we get into delta H on the potential energy curves. But for now, you should know that, hey, it's a reactant. The heat is a reactant, therefore it's endothermic. Okay, a couple of other just things I noticed. Again, what was that one thing I was going to say? When it comes down to this, the other big misunderstanding is that a lot of people, they try to like describe which way the reaction will shift. So when you're at equilibrium, right, and then you change something and it shifts like this, they say, oh, the reaction shifts to the right and then it shifts back to the left. Try not to do that. All I want to know is, hey, after you've added or changed something and you get this whole thing out of whack, what way does it have to turn to get back to level? That's what I want you to describe. When I say which direction will the reaction shift, don't I should say, ignore the first thing that gets the seesaw out of whack. So if you're at level and you get to like this, don't say it shifted to the right and now it needs to shift back to the left. Just say, okay, here I am. I'm at equilibrium. A change happened. Now, when you have to say which direction will it shift, all you say is the reaction has to shift now to the left to get back to equilibrium. And then start evaluating, well, if it shifts to the left, my reactant concentrations are going to go up and my product concentrations are going to go down, etc. All right? All right, I think the other exit slip was pretty self-explanatory. I gave you guys some direct feedback on that. So please check this one out here. I think this is the stuff that's the most challenging in this unit. So take your time, go over your exit slip. I'm about to post your video for activation energy. You'll have that today, and your exit slip will be due tomorrow. All right, guys, have a great day.